Hi, welcome to Easy Math. My name is Zishan, and today we're going to look into trigonometric identities from additional math. See, basically, there are two kinds of identities that you would want to remember. One of them is sine square plus cos square x is equal to 1, and the other one is tan of x is supposed to be equal to sine x by cos x. Every other identity that you're going to come across is a derivative of the first identity that we have here. And I have actually demonstrated how to find out the other derivatives, how to derive the other identities from the parent identity in this sheet right here. I don't want to go over the whole thing, but I would like you to know and understand how these identities would come about in the questions that we see in the past year paper. So these are the two identities we're going to use over and over again in your questions. So let's start with the questions. And we're looking at some past paper questions from Add Math. So let's look at the first one. Okay, so here we see we are supposed to show tan of x by 1 plus sec of x plus 1 plus sec of x divided by tan of x equals to 2 divided by sine of x for 5 marks. Okay, so what we do here is we first start by writing solving left hand side. I go start with the left side and simplify it in a way it looks like what we have on the right. Okay, so let's see. We go first take the LCM. Of course, the LCM here is gonna be the product of sec of x and tan of x. And up there, the tan of x is going to multiply with the tan of x. This is also going to multiply with that. So we're going to get a tan square x plus a 1 plus sec of x squared. Okay, now we go tan square x plus 1 plus, we're going to expand the bracket, 2 sec of x plus sec square x divided by 1 plus sec of x into tan x. Okay, now we can actually see a very nice identity coming about. See, look at that, tan square x plus 1. Well, that's an identity we have actually seen. I'll show it to you. There, look at that. Look at this one. Tan square x plus 1 is a sec square x. Where is it coming from? Well, it comes from the first identity. If you go do all of this, you'll see tan square x plus 1 is a sec square x. Well, I'm going to replace the tan square x plus 1 with our sec square x in the problem there. So there we go, sec square x plus a 2 sec of x plus a sec square x divided by 1 plus sec of x into tan of x. And now these two can be paired together. You get a 2 sec square x plus a 2 sec x divided by 1 plus sec of x into tan of x. Well, from there, I'm going to take a 2 sec of x out common, and you're going to end up with a sec of x plus 1 divided by 1 plus sec of x divided by tan x. Well, these two are going to cancel out, and you remain with a 2 sec of x divided by tan of x. Now, there are two things in here which we are again going to bring up from the sheet. I'll show it to you. See, look at these two. Sec of x. I said sec of x is supposed to be 1 by cos of x. Okay, so I'm going to replace the sec of x by 1 by cos of x, and tan of x from here is supposed to be sine of x divided by cos of x. Now that is going to be 2 by cos x divided by sine of x by cos of x, well, that is actually a product of 2 by cos x and cos x by sin x. These two cancel out. Well, you remain with a 2 by sin x. And when that's what you have on the right hand side, hence proved. Done. That's it. That is what you wanted. And yes, you get it, the right side. Okay, so that was one question based on identities. Let's look at the second one now. Okay, so I'm going to keep this to the left because we're going to go refer to it time and again throughout the video. Let's see. So here we have cosec x minus cot x divided by 1 minus cos x equals cosec x. So again, I'm going to start by simplifying the left hand side. So I'll go left hand side and we go pick up. Well, cosec x is supposed to be 1 divided by sine of x. And cot of x is supposed to be cos of x by sine of x. And that whole thing divided by 1 minus cos x, well, that's what you have. I've told you cot of x is actually supposed to be 1 by tan of x. And if tan of x is supposed to be the ratio between sin x and cos x, cot x is going to be the reciprocal of it, a cos x by sin x. And of course, cosec, right there, 1 over sin x. It's the reciprocal of sin x. So here we go. Take the LCM of sin x out here. You get a 1 minus cos x whole divided by 1 minus cos x. And then, you know, it's this divided by 1 minus cos x. That's what it can be written as. And then you go do this. 1 by 1 minus cos x is what you get. If you convert the division into multiplication, well, these two are going to cancel out and you remain with a 1 by sin x. And like I told here, it's a cosec x. There is your right hand side, hence proved again. So you see, what you have on the left, this whole sheet is to be used over and over again. There's no other reference that you need to solve the trigonometric identities. We're going to do one more. In fact, I've got 5 questions that I plan to do. Let us see. That's the third one. A little bit of algebra may also be used. So let's see. There. Well, what I have here in this equation that I want to prove is something which looks like a minus a b into a plus a b. Well, it looks like a minus a b multiplied by a plus b to me. Well, it's going to be a square minus b square. So, well, that becomes a 1 minus sine square x. Simple. Or sine square a in this case. And that divided by sine a cos a. Done. Okay. 1 minus sine square a by sine a cos a is where we are. Well, 1 minus sine square a, I can actually show it to you. There it is. 1 minus sine square x is a cos square x. So I'm going to replace it with a cos square a here. So you go sine a cos a. Well, there, these are going to cancel out. You're going to remain with cos a by sine a. Well, that's the reciprocal of tan, or that's literally a cot a. Done. And that's your answer. Equals RHS, hence proved. That's how you end your question. Okay, that was the third one. Let's look at the fourth one. Okay, they say prove that this equals cosec theta. Okay, fine. So cos of theta, cot theta is cos by sine plus a sine theta. Again, starting from the left-hand side, well, that becomes a cos square theta by sine theta plus a sine theta. Now, I'm going to take the LCM of sine theta here. I get a cos theta, cos square theta plus sine square theta. Well, that's the first identity. Cos square theta plus sine square theta is a 1. Well, there it is. Comes out to be a 1 by sine theta. Well, that's literally a cosec theta. That's the reciprocal of sine. cosec. There, you can see it here. Done. Okay, that was one more. Let's look at another one. How many marks for this one? We got 3 marks for this one. Okay, let's look at this one. Again, algebra. I see a minus b and a plus b here. The LCM would be a minus b into a plus b. Well, that's a square minus b square. There it is. And what are you going to get here? In the numerator is a 1 plus cos x and a 1 minus cos x. Well, that becomes a 2 divided by sine square x. Well, 1 plus cos x. Oh, no. Oh, that's a mistake. Wait, hold on. Okay. The LCM is going to be 1 minus cos square x. And in the numerator, you're going to get a 1 plus cos x and a minus 1 minus cos x. Well, that becomes a 1 plus cos x minus a 1 plus cos x divided by sine square x. Well, the 1 and the minus 1, they're going to cancel out. You're going to remain with the 2 cos x divided by sine square x. Well, the 2 cos of x, keep it just like that. Sine square x can be written as the product of sine x into sine x, right? Product of sine x and sine x. So here, what we do is we pair these two, cos x by sine x. When we do that, you get a 2 cot x. And then a sine x in the numerator, a sine x in the denominator can be taken up in the numerator, converted into a cosec x. That's it. Cos by sine is a cot. 1 by sine is a cosec. That's what you have on the right-hand side. Job done. Well, if you want to be a little more elaborate here, we can actually do it again. From here, we write it as 2 cos x by sine x multiplied by 1 by sine x. Now that should make sense. This whole thing can be written as that, and that whole thing can be written as 2 cot x into cosec x. Job done. Those are your questions. You know, that's how you do trigonometric identities. After you've been through these with me, I'll upload these on the website. You keep this on your screen maybe, or take a printout of it. It's an A4 size paper. After that, you go solve a few questions from this book. The book is also available online. I'll tell you what numbers you're going to have to do from the same book. This book is available for a free download on the website itself. I will show you the questions that you would want to do. You should be able to do, let's see, question number 303, 306, 309, 311, 314, and 316. For practice, all of them start from the page 365 onwards. Okay, so you go solve these questions. I have not done trigonometric equations here. I've only solved trigonometric identities. Next video, I'm going to upload about trigonometric equations, which are also going to be based on all of what we have seen here. A little bit of concept added. That's it. I'll see you, man. Bye-bye. Thank you.